The date was the 23rd of April, 1916. Major Peter Norman Nissen of the 29th Company, Royal Engineers, was attached to the headquarters of the 29th Division at Hesdin, a market town in the Pas-de-Calais, some 40 miles behind the Somme front. The weather had broken. War diary entries from that fortnight, held now at the National Archives in Kew under reference W.O. 95/2308, record an obsessive concern with one problem above all others: where to put the men. Nissen was not a professional soldier. He was a mining engineer from Halifax, Nova Scotia, who had trained at Queen's University in Kingston, Ontario, and made his money before the war designing stamp mills for South African gold operations. He had been commissioned into the 29th Company in March 1915 at the age of 44. An old man by trench standards. His expertise was structural, not tactical. And the structural problem confronting the British Expeditionary Force that spring was lethal. Field Marshal Sir Douglas Haig's preparations for what would become the Somme offensive required the concentration of roughly 400,000 men in the rear areas of Picardy. Existing French farm buildings could not accommodate them. The standard British Army bell tent, 16 feet in diameter and weighing 92 pounds, slept 15 men packed head to foot. In the wet spring of 1916, exposure casualties were running at a rate the Adjutant General's office described in a memorandum dated the 11th of April as incompatible with offensive readiness. Pneumonia, trench foot, and rheumatic fever were taking battalions out of the line before they had ever seen the line. Nissen's sketch, which he later said came to him over 2 days in a dugout at Olaine, addressed 3 constraints simultaneously. It had to be transportable by lorry or rail. It had to be erectable by unskilled labour in under 4 hours. And it had to use only materials already in the army supply chain, since nothing new could be requisitioned without War Office approval, a process that in 1916 averaged 7 months. The drawing, preserved in the Imperial War Museum's documents collection under accession number documents .4/471, shows a half-cylinder of corrugated iron, 16 feet wide at the base and 8 feet high at the apex, mounted on a timber sill and closed at each end by a wooden gable wall. The arc was supported by 7 T-section ribs of 3-inch by 2-inch steel, spaced 4 feet apart. The total weight was just under 2 tons. The bill of materials came to £27 and 10 shillings per hut at 1916 prices. Nissen built 3 prototypes between the 8th and the 21st of August 1916 at the Royal Engineers Depot at Hesdin. The Director of Fortifications and Works, Major General Sir George Scott Moncrieff, inspected them personally on the 25th. His report, classified at the time and now available at Kew under WO 32/5214, recommended immediate adoption. By the armistice, the British Army had erected approximately 100,000 of them across France, Belgium, Italy, Mesopotamia, and Salonika. What no one understood in 1916, because no one had any reason to test it, was that the shape Nissen had drawn to solve a logistics problem would turn out to be one of the most blast-resistant structures ever issued to a British soldier. That property would not be discovered for another 24 years, when the Luftwaffe began dropping 50-kilogram fragmentation bombs on dispersal aerodromes across East Anglia, and somebody at the Air Ministry finally thought to do the mathematics. The mathematics in question were not new. They had been worked out in principle by the French engineer Henri Navier in 1826 and refined by the German theoretician August Föppl in the 1890s. What was new in the spring of 1942 was their application to a problem nobody had previously bothered to solve: the behavior of a thin-shelled semicircular structure under transient overpressure from a high explosive blast. The work was commissioned by the Research and Experiments Department of the Ministry of Home Security, operating out of Princes Risborough in Buckinghamshire under the directorship of Reginald Stradling. The team responsible for the Nissen calculations was led by Dr. William Baker, later Sir William, a structural engineer seconded from Cambridge. Baker's report, RE and ED, reference number ARC/773, dated the 14th of June 1942, runs to 41 pages and is held at the National Archives under HO 196/12. The central finding was this: when a high explosive bomb detonates within destructive radius of a conventional building, the structure fails because its vertical walls present a flat surface perpendicular to the advancing pressure wave. A brick wall, 9 inches thick, the standard for British domestic construction under the Model Bylaws of 1877, will resist a static load of considerable magnitude. But blast is not a static load, it is a travelling discontinuity, a sudden step change in air pressure moving outward at approximately 1700 feet per second from the point of detonation. The wave arrives, exerts peak pressure for perhaps 3 or 4 milliseconds, then reverses into a negative phase as the displaced air rushes back to fill the partial vacuum. A flat wall has nowhere to send this energy. The pressure differential between its outer and inner faces becomes, in Baker's words, a couple acting upon a hinged plate. The wall fails at its weakest point, almost invariably the mortar joints, and collapses inward. The brick rubble then becomes secondary projectiles. The Nissen hut behaved entirely differently. Its semicircular cross-section meant that at any given point on the arc, the pressure wave struck the surface at a tangent rather than perpendicularly. The component of force directed inward into the structure was a function of the cosine of the angle of incidence. At the apex of the arc, directly above the centerline, this component was near total. But at the sides, where most of the structure's surface area lay, the pressure was deflected along the curve. The wave slid around the hut rather than punching through it. Baker's calculations, set out on pages 19 through 26 of the report, established that a standard 16-foot Nissen hut could withstand a peak overpressure of approximately 7 pounds per square inch without structural collapse, against perhaps 1.5 pounds per square inch for an unreinforced brick dwelling. Translated into bomb distance figures, this meant a Nissen hut would survive at 35 feet from a 500-pound general-purpose bomb. A brick house would not survive at 120 feet. There was a secondary effect. The corrugations themselves, the parallel ridges pressed into the galvanised sheeting at the Lysaght works in Newport, added stiffness in the longitudinal direction without adding mass. A flat sheet of the same gauge would have buckled at a fraction of the load. The corrugation profile, technically a sinusoidal wave with a 3-inch pitch and a 1/2-inch depth, had been developed by Henry Robinson Palmer at the London docks in 1829 for an entirely different purpose: the roofing of dockside warehouses. It happened, by accident, to be nearly optimal for the application Baker was now analysing. The Air Ministry circulated Baker's findings under cover of Memorandum CD/441 on the 2nd of August 1942, classified restricted. By that date, the empirical evidence had been accumulating in Norfolk for 2 years. The corrugated iron itself came almost entirely from one place. John Lysaght Limited operated the Orb Works at Newport in Monmouthshire, established in 1898 on a 40-acre site between the River Usk and the Great Western Railway. By 1940, the plant was producing roughly 400,000 tons of galvanized sheet steel a year, of which the War Office took priority allocation under the Essential Works Order of March 1941. The Nissen specification called for sheets of 24-gauge mild steel, though in practice the contracts let in 1940 and 1941 frequently substituted 16-gauge where the heavier material was available. Gauge in British metallurgical practice was an inverse measurement. 24 gauge corresponded to 22 thousandths of an inch in thickness, 16 gauge to 64 thousandths. The difference mattered. 16 gauge sheeting weighed roughly 2¾ pounds per square foot, against just under 1 pound for the lighter material, and offered correspondingly greater resistance to fragmentation from near-miss explosions. The galvanizing process took place in a continuous bath of molten zinc, maintained at 450 degrees Celsius. The sheets emerged with a coating of approximately 3 ounces per square foot, which gave the finished hut its characteristic dull silver finish before weathering turned it to the streaked grey-brown familiar from every wartime photograph of an RAF dispersal aerodrome. The zinc layer was not cosmetic. Bare steel sheeting of that gauge, exposed to British weather, would have failed by perforation within 4 years. Galvanized sheets at Catterick Garrison, erected in 1917, were still weatherproof in 1945. The corrugation pattern was rolled into the sheets at the Orb Works on a 5-stand mill commissioned in 1926. The standard Nissen profile used a 3-inch pitch with a depth of approximately 5/8 of an inch, slightly deeper than Palmer's original 1829 specification. This deeper corrugation increased the section modulus, the geometric property that determines a beam's resistance to bending, by a factor of roughly 11 over a flat sheet of equivalent mass. It was this property, more than the steel itself, that gave the Nissen hut its peculiar mechanical character. When a blast wave struck the curved roof, the corrugations acted in 2 directions simultaneously. Along their length, running from gable to gable, they functioned as shallow beams, stiffening the structure against longitudinal buckling. Across their width, they permitted a small degree of elastic deformation as each ridge flexed independently. A brick wall, struck by overpressure, either stood or fell. A corrugated sheet flexed, absorbed energy through elastic strain, and returned to shape. Engineers at the Building Research Station at Garston, Hertfordshire, recorded huts that had visibly distorted under blast loading and then snapped back into their original geometry within seconds. The fastenings were equally important. The sheets were attached to the T-section ribs by hook bolts of 5/16-inch mild steel, threaded at one end and curved at the other to pass over the rib flange. Each sheet carried 12 such bolts, with the heads bedded on lead washers that compressed to form a weatherproof seal. The bolts themselves were specified to fail in tension before the sheet tore, a deliberate design choice that meant catastrophic blast loading would strip individual panels from the structure rather than collapsing the whole frame. Lysaght's wartime output of Nissen pattern sheeting reached an estimated 410,000 tons between September 1939 and August 1945. Distributed across the empire by rail, lorry, and the merchant convoys that ran from Newport docks to Halifax, Alexandria, and Bombay, it clothed perhaps 170,000 huts of all variants. Brick, by contrast, took 6 weeks to fire and could not be shipped economically further than 50 miles from the kiln. The empirical confirmation of what Baker would later calculate on paper began on the 11th of August 1940 at a Royal Engineers experimental range at Bridgham, 8 miles southeast of Thetford in Norfolk. The trials were conducted under the authority of the Directorate of Works at the Air Ministry in cooperation with the Research and Experiments Department and prompted by a specific operational concern. The Battle of Britain was 3 weeks old. The Luftwaffe had begun systematic attacks on fighter command aerodromes on the 12th of July. Dispersal hutting on those stations was already taking damage, and the Air Ministry needed to know, with some urgency, whether the standard 16-foot Nissen offered any meaningful protection to the personnel and equipment housed within it. The trials officer was Major Cyril Helsby, Royal Engineers, attached to the experimental establishment at Christchurch in Hampshire. His report, designated AM/RE/7/1/40, ran to 23 pages with 17 photographic plates and is preserved at the National Archives under AIR 2/4/488. The procedure was methodical to the point of pedantry. 5 Nissen huts of standard pattern were erected at Bridgham between the 4th and the 10th of August by a section of the 241st Field Company. Each hut was furnished with a representative load: 3 pairs of single iron bedsteads, a coke stove, a deal table, and 4 wooden chairs. Sandbags filled to standard weight were arranged at the bed positions to simulate sleeping personnel. The huts were designated Alpha through Echo and positioned at measured distances from a central charge point. The charge was a single 500-pound general-purpose bomb of the type then in standard Luftwaffe service, the SC-250 multiplied by 2 in approximate British equivalent. The actual ordnance was a captured German weapon recovered intact from a crash site at Hawkinge in late July and rendered safe at the Royal Arsenal at Woolwich. It was detonated at 6 feet above ground level, suspended from a timber gantry at 940 hours on the 11th of August. Hut Alpha, at 25 feet from the detonation, was destroyed outright. The steel ribs sheared at the sill plate, the sheeting was thrown some 70 yards downwind, and Helsby's report noted that no occupant could reasonably have survived. Hut Bravo, at 50 feet, suffered severe distortion but remained standing. 3 of its 7 ribs were buckled inward, and the south-facing sheets were perforated by some 42 fragments, but the gable walls held, and the sandbag occupants at the bed positions were judged to have been survivable casualties with serious but non-fatal injuries. Hut Charlie, at 75 feet, was the critical case. The structure remained essentially intact. Sheeting was dished inward by perhaps 2 inches at the point of closest approach. 4 of the lead washers had failed, and the eastern gable showed cracking along its boarded surface. But the interior was substantially preserved. The sandbags at the bed positions were undisturbed. Helsby concluded that personnel sleeping in such a hut at the moment of detonation would in the majority of cases have suffered concussion and minor lacerations only. Huts Delta and Echo at 100 and 150 feet respectively were superficially damaged by fragmentation but structurally untouched. Helsby's recommendation, set out on page 19 of his report, was that Nissen hutting should be retained as a standard dispersed accommodation across all RAF stations, with the proviso that huts be sited no closer than 60 feet from any anticipated point of attack. The Air Ministry adopted this guidance on the 3rd of September 1940. Within 3 months, it would be tested under conditions Helsby had not envisaged. The night of the 14th and 15th of November, 1940 is remembered in Britain principally for what happened to the cathedral. Operation Moonlight Sonata dispatched 515 aircraft of Luftwaffe 3 from airfields in northern France to attack the city of Coventry in the West Midlands. The first bombs fell at 1920 hours. By dawn on the 15th, 568 civilians were dead. 4,330 buildings in the central wards had been destroyed or rendered uninhabitable, and the medieval cathedral of St. Michael was a roofless shell. What is less remembered is what happened at Baginton. Baginton Aerodrome lay 3 miles south of the city centre on the edge of the village of the same name. It had been requisitioned in 1937 and developed jointly as a civil aerodrome and a Royal Air Force station. By November 1940, it housed No. 308 Polish Fighter Squadron, flying Hawker Hurricane Mark Is, together with the Armstrong Whitworth factory that was producing Whitley bombers at a rate of approximately 14 airframes a month. The dispersal accommodation for ground crew, fitters, riggers, and the squadron's Polish pilots consisted of 43 Nissen huts of standard 16-foot pattern scattered around the airfield perimeter at intervals of roughly 80 feet. The Luftwaffe bomber stream passed directly over Baginton on its approach to the city centre. Stragglers, aircraft that had failed to identify the principal target or had been driven off course by anti-aircraft fire over Birmingham, jettisoned their loads on or near the aerodrome between 2100 hours and 0100. The Operations Record Book for Baginton, AIR 28/33 at the National Archives, logged 11 separate impacts within the perimeter that night, comprising an estimated 750-kilogram and 4 250-kilogram high explosive bombs. The damage report, completed by the station engineer officer on the morning of the 17th, makes instructive reading. 2 Nissen huts were destroyed. Number 17, which had taken a direct hit on its eastern gable, and number 29, which had been within 15 feet of a bomb crater. 6 others were badly damaged, but repairable. The remaining 35, including several within 60 feet of detonation points, were operational by the morning of the 16th after the replacement of perforated sheeting and the reglazing of gable windows. Within the same period, the village of Baginton itself, half a mile south, lost 9 cottages of Victorian brick construction to 2 bomb impacts in its main street. The aerodrome, with a far greater density of high-value targets, lost the equivalent of less than 5% of its dispersed accommodation. The pattern was repeated across the city. At the Daimler Shadow Factory at Radford, Nissen pattern stores buildings survived the destruction of the main brick assembly halls. At the Standard Motor Company's works at Canley, Nissen offices, erected in 1939 for the dispersal of administrative functions, came through the night with broken windows and superficial fragmentation damage, while the original Edwardian works were gutted. The Coventry City Engineers Report of the 22nd of November is preserved in the City Archives at the Herbert Art Gallery under reference P. A. 242/1/1, records that of the 111 Nissen and Nissen derivative structures within the city boundary, 97 were habitable within 48 hours of the raid. The Air Ministry's bomb damage assessment branch, established only the previous month under Group Captain John Whitworth Jones, took particular interest in the Coventry figures. Their report of the 8th of December, 1940, AIR 20/4/611, recommended that Nissen hutting be specified as standard for all dispersed industrial accommodation under the Beaverbrook Shadow Factory program. The recommendation was accepted within a week. By the spring of 1941, the basic 16-foot hut had begun to multiply into a family of derivatives. The pressure for variance came from a simple operational fact. The original Nissen had been designed in 1916 to house 24 men with their kit. By 1941, the British war effort needed to house Hawker Hurricanes, Bristol Beaufighters, Bedford lorries, and eventually the Sherman tanks that would arrive under Lend-Lease from March 1942 onwards. None of these would fit through a 16-foot door. The first significant enlargement was the Romney hut, named after the marshland in Kent, where the prototype was assembled in May 1941. It was developed jointly by the Directorate of Fortifications and Works under Major General Donald McMullen and the Iron and Steel Federation, drawing on the structural principles Baker would formalize the following year at Princes Risborough. The Romney spanned 35 feet at the base, rose to a clear interior height of 17 feet at the apex, and could be erected in any length up to 96 feet by adding standard 4-foot bays. The Romney used the same corrugated galvanized sheeting as the Nissen in 22 gauge, but the ribs were heavier. Each rib was fabricated from 2 pressed steel channels bolted back to back to form a tubular section 3 inches by 4, with a wall thickness of 3/16 of an inch. The ribs were spaced 6 feet apart and braced longitudinally by tubular purlins of 1.5 inch nominal bore. The total weight of a 60-foot Romney came to approximately 11 tons against just over 2 for the standard Nissen. A 4-man section of Royal Engineers could erect one in 14 hours. The Romney's principal application was aircraft maintenance. From mid-1941 onwards, it appeared on every operational and training aerodrome of bomber, fighter, and coastal commands as the standard hangar for routine servicing and minor repair. The maintenance unit at RAF Fylingdales in Flintshire received its first Romneys in August 1941. By the end of 1943, approximately 3,700 Romneys had been erected across the United Kingdom, with a further 900 shipped to North Africa, the Mediterranean Theatre, and India Command. The Iris hut, slightly smaller at 30 feet span, was developed in parallel for transport and ordnance storage. Its name was a War Office abbreviation for Indian Reinforced Iron Structure, reflecting its original specification for service in the Burma campaign, where teak frame buildings were vulnerable to monsoon rot and termite infestation. The Iris used a double skin construction with an air gap of 2 inches, which gave it a measurable thermal advantage in tropical conditions and, incidentally, a marginal improvement in blast resistance over the single-skin Nissen. Smaller derivatives also appeared. The Hospital Nissen, developed by the Royal Army Medical Corps at Boyce Barracks at Crookham in Hampshire, extended the standard 16-foot hut to a length of 60 feet and added insulated cladding to the interior. The handcraft hut, used by the Air Training Corps and various ancillary services, reduced the span to 12 feet for individual office accommodation. The curved asbestos roof building, or CARB, substituted asbestos cement sheeting for galvanized steel in applications where electromagnetic shielding was a concern, principally radar receiver stations along the chain home network. The unifying principle remained Nissen's original insight. The semicircular arc, scaled up or down, retained its blast-resistant geometry. Baker's calculations at Princes Risborough had established that the cosine relationship between angle of incidence and inward pressure component held regardless of absolute dimension. A 35-foot Romney was, in proportional terms, no more vulnerable than a 16-foot Nissen. The shape worked. The scale of construction required for Operation Overlord has rarely been properly conveyed. The figures, set out in the 21st Army Group's administrative history compiled in 1947 and held at the Royal Logistic Corps Museum at Worthy Down, are difficult to assimilate even now. Between the 1st of January and the 5th of June 1944, the southern counties of England received an additional 1,200,000 troops above their pre-existing garrison. Every one of them required accommodation, mess facilities, latrines, vehicle parks, ammunition stores, medical reception centres, and briefing rooms. The solution was Nissen hutting on a scale that exceeded anything attempted in the First War. The Quartermaster General's establishment, then under Lieutenant General Sir Wilfrid Linsell, calculated the requirement at 68,000 huts of various patterns to be erected between the autumn of 1943 and the early spring of 1944. The geographical distribution concentrated on Hampshire, Dorset, Devon, Sussex, and Kent, with secondary clusters in Berkshire and Wiltshire for the airborne formations training around Salisbury Plain. The largest single concentration was at marshalling Area C, covering the New Forest and the country between Southampton Water and the Avon Valley. 11 subcamps were established within this area, each accommodating between 3,000 and 11,000 men in standard 16-foot Nissens supplemented by Romneys for vehicle maintenance and Iris huts for stores. Subcamp C11 at Lepe, on the Solent shore opposite the Isle of Wight, was constructed in 23 days between the 14th of February and the 8th of March, 1944. Its final establishment, on the day before the troops moved in, comprised 473 Nissen huts, 61 Romney workshops, and 18 Iris store buildings, together with the cookhouses, ablution blocks, and water points required to support a brigade group. The erection rate achieved by Royal Engineers Field Companies and the Pioneer Corps during this period has not been equalled. A 4-man section, working from a prefabricated kit delivered by lorry to the site, could complete a standard Nissen in just under 6 hours from arrival of materials to weatherproofed structure. The kit contained 283 separate components, every one of them numbered and listed on an inventory card carried in a waterproof pouch attached to the timber sill bundle. Nothing was cut on site. Every sheet, rib, bolt, and washer had been prefabricated at Lysaght at Newport or at the parallel rolling mills at Britton Ferry and Gowerton, and dispatched by rail to depots at Bicester, Donington, and Histon. The huts at the marshalling areas were not expected to be permanent. The administrative plan, drafted under Major General Miles Graham at 21st Army Group Headquarters at St. Paul's School in Hammersmith, anticipated that the camps would empty progressively from the morning of the 6th of June onwards and be available for return to agricultural use within 12 months. In practice, the demands of the Normandy campaign and the subsequent advance into the Low Countries kept many of them in continuous use until well into 1945, with replacement drafts from the holding battalions passing through on a rolling basis. What is striking, when one reads the post-operational reports of the marshalling area camps now held at Kew under WO 205, is how rarely the structures themselves are mentioned. They had become invisible. The Nissen had ceased to be a piece of equipment and had become simply the environment in which the British soldier lived, slept, ate, and prepared for action. Its shape was so familiar that nobody noticed it anymore. That familiarity was about to prove a problem. Peter Nissen did not live to see his hut accommodate the soldiers of 21st Army Group. He had died on the 2nd of March, 1930, aged 58, at his home at West End in Surrey, of complications following a long illness contracted during his service in France. His estate, recorded in the probate calendar at Somerset House at £6,841, included royalty income from the patent he had registered on the 7th of August 1917, number 128456, in the British Register. The patent expired in 1933. By the time the Second War began, the design had been in the public domain for 6 years, and no one was paying anyone for the privilege of building it. The hut outlasted both its inventor and the war for which his variant designs had been refined. The Cold War kept it in service. The early warning radar station at RAF Fylingdales on the North York Moors, operational from the 15th of September 1963, used Nissen and Romney hutting for technical support buildings alongside its three Mark I ballistic missile early warning radomes. The American Air Force installation at Greenham Common in Berkshire returned to operational use in 1968 for the deployment of BGM-109 Tomahawk cruise missiles a decade later, retained substantial Nissen accommodation throughout its active life. The experimental research establishment at Orfordness on the Suffolk coast, where Cobra missed over-the-horizon radar was tested between 1971 and 1973 at a transmission frequency of 6 to 40 MHz, operated from Nissen huts erected during the Second War and never replaced. The Royal Engineers Specification 598, issued in 1946, and reissued with minor revisions in 1953, 1961, and 1972, kept the standard 16-foot Nissen on the Ministry of Defence's catalogue of approved structures until the 7th of April 1985. On that date, it was formally withdrawn from issue and replaced by the Portakabin pattern modular building, a flat-walled steel-frame cabin manufactured at Huntington in North Yorkshire. The replacement structure was easier to transport, faster to commission, and offered superior insulation. It was also, by any structural measure, markedly less resistant to blast. What followed was a quiet demolition campaign that no published Ministry of Defence document has properly explained. Between 1985 and approximately 1998, the great majority of surviving Nissen huts on British military estate were dismantled and removed. Some were sold to agricultural users for conversion to barns or workshops. Many were simply scrapped, the corrugated sheeting baled for export to the steel recycling plants at Sheerness and Cardiff. The Defence Estate's returns for the financial year 1993 to 1994 record the removal of 2,411 Nissen pattern structures from sites in the United Kingdom alone. A reasonable estimate of the number of Nissen huts remaining in identifiable military configuration on British soil in the year 2026 is somewhere between 400 and 600. The Imperial War Museum holds 3 preserved examples, 2 at Duxford and 1 at the IWM London store at Duxford's south site. The Yorkshire Air Museum at Elvington maintains 4 in operational condition as period-correct accommodation for visiting reenactment groups. A small number remain in continuous occupation as private homes, principally in Cornwall, Suffolk, and the Scottish Highlands, where the original wartime occupants or their successors purchased the structures from the Air Ministry under disposal sales between 1946 and 1949. The shape that nobody understood in 1916 and that Baker's calculations explained in 1942 is now disappearing from the British landscape. The reason it survived bombs is the reason it should have survived peace. It did not.